Great, thanks so much. And thanks everyone for making time today. I'm going to move at a very quick pace because 30 minutes is going to go quickly, and want to be sure we leave some time at the end for questions. My topic was about ChatGPT being 20 years too late, and that's largely because in the education space, AI has been used extensively for multiple decades to do a lot of work that's very similar. Before we get into that, though, I want to sort of introduce where I come from, sort of set up our bona fides and go from there. So we're a US-based company, Vantage Labs. All of you probably use our technology every day. We built the grammar checker and spell checker that's in Microsoft Office. If you're not a Microsoft user and you have an iPhone or an iPad, go look at the little gear under the general about legal notices, and you'll see 14 of our patents that allow Siri to talk to you in a natural language way. So we touch about 2.2 billion customers a day, including, again, most of you. This session is again focused on how AI is impacting education, and know that we do about 100 million assessments annually. That's a huge number, and probably the biggest in the industry, because we work with folks like Graduate Management Admissions Council. So all of you who've taken the GMAT exam in the last 20 years, we scored your essay with an AI technology and did it better, faster, and cheaper than humans. All that technology got started in 1997 and has since really just sort of continued to flourish and grow in a lot of different ways. But as you'll hear in a minute, it's also where I think ChatGPT is going to run into some pretty significant burden in terms of penetrating the market. Those of you who listened to Eric Riz's presentation just before me, there's a question about how it's going to impact education. And I'll tell you, I think it's going to impact it in a couple different ways, but it's certainly going to be a lot slower than most realize. Some of the folks we work with in the education space, it's sort of a who's who in that list. I had mentioned Graduate Management Admissions Council, Microsoft's on here, Apple's on here, the US Citizenship and Immigration Services, United Nations, and then a lot of other large universities who are all leveraging our AI technologies. But our technologies for AI are a little bit different than what you just heard from Eric on generative AI, because we're actually on the receptive side. So in language, for those of you who aren't familiar with this, in language, there's productive language, that's me talking, and there's receptive language, that's you listening, right? Same thing with in the written form, someone writes something that's productive language. Receptive is when you read it and can read it, understand it, comprehend it. Where ChatGPT and that whole generative AI industry that's exploded over the last 6 months comes in, they're really more on the production or the generative side of AI. We're on the receptive side, and the receptive side has been out there for a lot longer, which is kind of ironic because when learning a language, receptive language is actually a little bit harder at times for certain individuals. Our AI system achieved human level scoring more than 2 decades ago. And what I mean by that is we were able to surpass humans, expert humans, who did this. And over time, the technology's gotten better and better and better. We use a slightly different approach than what ChatGPT does or some of these large language models. And we'll talk about that in greater detail. This has since been extended out. It's not just about the written word, but it's about the spoken word and answers of all sorts of lengths. It's also about content that can be analyzed in multiple languages. So we can score just as well in different languages as we do in English. It's not just an English-based system. One of the other interesting things, as you've been playing with these generative text machines, you've probably found that there is a lot, as Eric noted, there's a lot that goes into the input. The output is really driven a lot by the input. And we found that similarly, we can discover a lot of interesting things based on the input to this receptive engine called Intellimetric. At this point in time, if you were to give me a writing sample from each of the people in the audience, I'd be able to actually take a diagnosis of whether or not and how severe it was you were on a language-based learning scale. So do you have dyslexia, attention deficit disorder, ADHD, something like that? And given that 1 in 5 individuals in this country has some form of that language-based learning difference, the fact that I can identify that and suss that out with AI is a pretty impressive thing that used to cost $3,000 or $4,000 in 2 days of testing in a psychologist's office. I'm putting this all into perspective, in particular because we love ChatGPT. We think it's awesome that it has really blown up the idea of AI in the classroom and in education in general. I want to take you on a quick tour of history in education and innovations in education. And if you see here some quotes, there's one from 1815 about students depending too much on paper. They don't know how to use a chalk and slate. Imagine that, right? If our kids today didn't carry around notebooks, they carried around a chalk and slate, which is really almost where we were back to with tablets and computers. They're not carrying around a paper, but they're carrying around a new device. In 1907, the National Association of Teachers were upset that students would know students would only use the pencil and they wouldn't know how to use would only use pen and ink, and they didn't want them to forget how to use the pencil. And just think about that. Back when I was in elementary school, I think we were still writing with a straight pen and nib. The students today are dependent too much on store-bought ink. They're not going to know how to make their own ink. Think about that, right? Now, this was quite some time ago, but teachers were resistant to things like pens and paper. Fast forward a little bit further to 1941, we're getting more modern here. Students depend too much on expensive fountain pens, right? They can't write with a straight pen and nib, right? And again, that was in 1941. I was still writing with a straight pen and nib when I was in elementary school. And while I'm probably older than most of you, I'm not that old. That should be pretty surprising to most people. In 1950, they thought ballpoint pens will be the ruin of education. Literally, they said, the Federal Teacher magazine came out and said it would be the ruin of education to use a ballpoint pen. And think of all the ballpoint pens we have today. So contextualizing this, think about ChatGPT and the resistance people are starting to put up already to ChatGPT. Should we use ChatGPT? Can it be in the classroom? That was literally the first question that Eric Riz, the presenter before me, got, is how are we going to restrict this, or who should be responsible for or managing this and restricting it? And the reality is education will restrict it on its own, right? Nature will take care of a lot of this. Students today depend too much on handheld calculators. That was 1984. I'm sure many of you probably remember 1984. And if you look to the right, there's actually a newspaper clipping I found of teachers picketing outside the school because they want to protest the use of calculators. Now we give students calculators and we encourage them to use it. Think of the calculator like ChatGPT just 40 years ago. And just last fall, I was meeting with a minister of state in the United Kingdom, and he said, we cannot do online testing. We can't take a test in an online environment on a computer because students' handwriting will degrade too far. And when we think about that in light of COVID, when every testing program went to online testing, we know that those things just aren't going to stick around. And I'm just about done making this point. I'll drive it home for everyone. This isn't just restricted to education, right? In 1908, a U.S. congressman thought automobiles were far too difficult to work with because you had to use your hands on the steering wheel and you had to use your pedals at the same time on the gas and the brake and the clutch and then move a shifter. And this was just too much. So we can't possibly do away with horse and buggies. Western Electric in 1876 said that no commercial use for the device, referring to the telephone. And now most of us carry one or two telephones with us at all times in our pockets. IBM thought the idea of a personal computer wasn't ever going to happen in 1980. And for those of you, again, old enough, I owned an IBM PC Junior, which was one of the first mass-produced PCs on the market. We used to have cartridges we had to put in to load more memory and content into that. And then I imagine some of you are probably, or would have said, maybe a few years ago or before ChatGPT rolled out, that computers can't possibly score an essay better than a human. And the reality is, not only can they do it, the early work on this started in the 1960s. And since then, we've only gotten better. In around the 2000s, we really took off and we've really just sort of surpassed human performance. And then again, someone will probably say ChatGPT is going to radically change education. It's going to solve all of our problems. And the reality is, I think, yeah, it's going to solve a lot of issues. It's going to cause a lot. And there's going to be a tremendous amount of resistance to how ChatGPT works in the field. So as you see here on screen, there are the work in this field of using a machine to do a human task in particular in the classroom, relative to scoring a piece of text and scoring it more reliably than humans, started in the mid to late 1960s with a gentleman named Dr. Ellis Batten Page down in North Carolina. And Dr. Page was literally loading data on paper punch cards. So again, I can't see all of you, but I'm imagining or hoping some of you are at least as old as I am and remember there was a time when we loaded data into computers on paper punch cards. And when we did that, right, we had to hope it wasn't a windy day and our cards didn't get out of order, or we'd have to restack everything before we could load them into the machine. But in the 1960s, machines were scoring content and written work better than humans were. We fast forward into the 1970s and we started to see latent semantic analysis. And this is really a precursor for what you're going to get with the large language models and these statistical models that are coming out. Knowledge Analysis Technologies was a company out of Boulder, Colorado. They built some really interesting stuff. They definitely focused a bit more on content than on just the written prose that was out there, but they were getting good features as well. If you fast forward into the 1980s, natural language processing became popular in this area, largely because the computer power started to take great leaps. If you remember Moore's law from Intel, we would see this advent of chips, every 6 months they were doubling in capacity. And so natural language processing really started to get its launch in this field with an engine called E-Rater. And that was out of the group called ETS, a nonprofit in New Jersey. In the mid-1990s, we started to see machine learning, which was really starting to take a blend of some of what LSA was doing, some of this machine learning on knowledge sets. And then we really broke a barrier in 2000, where we rolled out what we call Intellimetric, which is an AI engine that can score a free text response. It just does it better, faster, and in less than 1 second. It's actually about 1/100th of a second of time. And it performs like a human would. It reads the piece of text and understands what's written there. It can make critical judgments about that text and then go to the next level. So again, I want to just be clear. We're not generating this text. We're taking human input text. We're analyzing it. We're scoring it as though a human would. And we're making those judgments about how that happens. So how is an Intellimetric model created? Well, we basically take previously marked scripts. There's a combination of some AI going on here, some machine learning, some underlying tools in the linguistic space. We take essays, we feed that into the engine, and we say, okay, here's how the human rated a particular set of papers. It goes through a processing phase where we're literally doing linguistic imaging of every sentence that we find, so that we can understand language variety. We start to extract things and look for all the different meanings of words. I take a good example often when I talk about this. If you think of the word back, 4 letters, B-A-C-K, and think of all the meanings for the word back. It's a direction. I can move back away from my machine. It's part of my anatomy. I can pat myself on the back. But you probably hadn't thought of the word wager or bet. Well, the engine was able to think of that because the engine understands if you back a horse in a race, you're betting on a horse. So in this text processing phase, we're breaking out all of these components. We're looking at a syntax analysis. We're extracting a little over 530 different features of writing or of written text so that we can better understand it. We then go into this computational analysis process. Where we're doing this, we're looking at a vocabulary, a giant concept net, because we want to understand words have meaning only when we see them in context. And part of what's happening here isn't just the statistical models that you're seeing from these large language models. We're literally using a rules-based approach. With a bit of a head start on folks like ChatGPT, we had decades of experience where we literally hard-coded in all of the rules of a language so that it was understood at a rule basis. And that's really challenging if you know much about language, because language is confounding. Sometimes one mistake early in the sentence will break 3 other issues down the road, or one mistake early in a sentence will fix 3 other issues down the sentence. And so the engine is using a variety of different processes, both our rules, some statistical measures, a number of different features that I'll talk about in just a minute, goes across these multiple measures, these judges that we've built. This is where the AI comes in. Each judge analyzes the text in a slightly different way, and it eventually resolves to a final score. And that score is literally more likely to match what 10 expert humans would give a paper than if you brought in 10 teachers from the classroom and said, judge this paper and score it the way you think it should come out, if all were trained the same way. So how do we do this? We do this with what we call a neurosynthetic approach, and understanding that you've got to understand a little bit about how your brain and my brain read, because that's essentially what we've done. We've reproduced the organic process of reading. When your brain and my brain read, we don't just suddenly sit down and understand words on a page, right? There's a lot of different components that go into understanding language. And the other important thing to remember is that the printed word is a very modern evolutionary trait in humanity, right? We were wired for spoken language, not for written language. And so what we've done, if you look on the left-hand side here, is we've built a series of engines that handles each of these different threads. These are these judges that we talked about on that previous slide. We have judges that understand background knowledge. Your background knowledge happens in the back part of your brain, right? So we're looking at cognitive science and how is that encoded in the brain? We literally look at oxygenation levels in the brain. We try and understand how words are encoded biologically so that we can then build a machine that does that same component. So this engine is understanding facts and concepts, right? But it also has vocabulary. As I used the term before, back has a lot of different meanings, and we want to understand that vocabulary. Is it appropriate, and how much does it weight in that process? We look at language structures like syntax and semantics. That seems probably clear to many of you if you knew that we built the grammar engine in Microsoft Office, right? We understand grammar and syntax, those pieces. Verbal reasoning, this is a really hard area. This is an area that we spent probably well over 27 months working on, millions of dollars, because you're really trying to get an inference out of a piece of text, and developing the sense of what an inference is or what a metaphor is, and is it used appropriately, is a challenge, because there's a little bit of gray in that. There's a human element that comes in that is really hard to reproduce. On through to literacy knowledge, different types of writing, right? Persuasive writing uses some types of language. Narrative writing uses a different type of language. We build all these components in, and then we tie it back into some of, again, these biological processes like phonological awareness, right? Believe it or not, even though we're measuring text on screen that doesn't have sounds per se, we want to understand the phonemes, right? Which are the sight sound correspondence, the sounds that letters or combinations of letters make, because then we can understand when there are misspellings, and how do we handle that? We can understand phonemic or phonetic spelling, and the engine literally is behaving like a human because we do all this, on through to decoding and sight recognition. All of these different judges or engines, right, get tuned up. They understand how the human was behaving with something, and we weave those all together until it becomes skilled reading. That's exactly what your brain does. This is actually a model from a developmental psychologist named Dr. Hollis Scarborough. Happens to be my wife's graduate advisor, so I'm a little well-versed in Scarborough's model here. So what makes our system a unique, and how does it sort of, what's the next level with this? Again, there are more than 500 semantic, syntactic, and discourse level features. This isn't a pure statistical model. Again, we're looking at rules, we're looking at concept engines, we're looking at linguistic images of sentences, and we're taking all those different components, we're marrying those together with the AI. It's weighting those based on what it's learned from the input training data. It is a learning engine. So while it has all of these tools, we do want to feed it so that it scores according to the local standard. The rubric we use to score the GMAT papers is very different than the rubric I use to score papers for the Ministry of Education in Singapore. In fact, the Ministry of Education in Singapore uses a 6 as a low score and a 1 as a high score, whereas the GMAT, it's 1 as a low score, 5 as a high score. So it's actually flipped, but the engine learns that. Same thing happens with Chinese, with Spanish, with Arabic, depending on what we're scoring. It is systemic in that the engine does have these systemic features that it's looking for, some systematic approach to scoring any piece of writing. So we can build a non-prompt specific engine that'll generally score the way a typical average human would. But when you want to get really surpast those humans, you've got to build these custom models. It is an inductive engine. Again, it's learning. It's using multiple judgments, much like James Surowiecki wrote about in his book, Wisdom of the Masses, right? The more judgments you have, the more likely you are to get the right answer. And that's why we use multiple judgments in this process. The engine is sophisticated enough also to say, hey, this paper, this shouldn't get a score. It's off topic, it's too short, written in a foreign language, written with foul or threatening language. The terrifying thing, and particularly in light of the news this week at that school in Tennessee, we get about 1 suicide note a month. And the difference with the AI is we're able to apply that AI and get a school resource officer into the classroom within 15 minutes, usually of receiving one of those responses. So I want to tie this back into ChatGPT because I think ChatGPT is a really awesome, powerful tool. And as Eric said, it's not going away. So I think people are going to fall into one of 3 camps, right? You're either going to be the Icarus crowd, that you fly too far, too fast, and you get too close to the sun and you burn up. And I think there are a lot of people out there right now. So as you start looking at this, in particular in light of the education market, people are telling you, oh, ChatGPT can give me instant feedback on my papers. And yeah, it can give really powerful feedback, but it also has these, what the industry started to call hallucinations, and it's starting to give improper feedback. A professor I know was asked, hey, professor, I wanted to cite your paper that ChatGPT had referenced. Where can I find it? I can't seem to get it in the library. And he said, I never wrote that paper. So we're finding more and more that these little hallucinations come up. And anytime you use a statistical model, which is really where ChatGPT is using, you're going to run into gaps, right? Because there's lies, damn lies, and statistics. So be careful. Don't run too far, but definitely don't do what the next category is, which is don't be a Luddite, right? This technology, I've talked at a number of different universities where they said, we're banning this. New York City Public Schools banned ChatGPT. And I just sort of asked the question, how'd banning alcohol go for this country, right? It didn't go too well. Banning it from students is like an invitation for them to figure out how to work with it. And then there's everyone else. Those of you who are on this call, probably here to learn and not hear what's going on in the industry. You're probably already doing things with it. That's awesome. I think you should continue to do that and take it in different directions. Just be a little bit careful, because in the education marketplace, when you stumble a little bit, it sets everyone back pretty substantially. Eric mentioned a lot of this on the last call, or the last presentation, so I'm not going to touch too much on all of these details and leave a little bit of room for question and answer. But some notable things. Again, ChatGPT was not the first. Bard, probably everyone got their invitation to Bard in the last couple of days. Bard's a little bit behind in places. It was ahead of ChatGPT. And what we found working, because we work with Amazon, we work with ChatGPT, or with Microsoft, we work with Google, we see this sort of a horse race. Like, these guys are neck and neck on these models and a lot of things. And so I would encourage you to just remember there are others out there, and don't put all your eggs in one basket. Remember that this is a for-profit venture, right? Microsoft didn't pump billions of dollars into it to just give away everything. So if you build an entire model around the free services, heavy caution that they're going to come back at some point and start charging you for that. Build that into your model. I think a lot of the criticisms about ChatGPT, those are human failings, not machine failings. The machine is really slick and really cool, right? A lot of people tell me, oh, students are going to use this to cheat. Well, guess what? Students have been cheating since the dawn of time, right? This is a human issue, not a technology issue, right? You can't always fix human issues with technology. So keep that in mind. Humans are going to continue to cheat. That doesn't mean you then build another technology to stop them from cheating. You engage them in the process. Talk to them, as Eric mentioned, about why are you cheating, right? Don't you want to learn? Don't you want to be able to write, so that when ChatGPT isn't available to you, you can actually write something? And I think generally what we found in our market research is that students actually do want to know how to write. They want to know how they can use ChatGPT to better purposes. I think certainly you have to be careful about the unethical purposes of disinformation, right? This is not a ChatGPT issue, though. Again, this is a human issue. Humans were pumping out disinformation, back before we had computers. They're going to continue to do it now and just do it faster. Answers are incorrect, right? That just means that humans need to learn how to use the technology. The same way ChatGPT has these hallucinations. Think back to that picture I showed you of the math teachers complaining about calculators. You can put the wrong input into a calculator, you're going to get the wrong scores. You better know the math ultimately in order to handle that. It's in commercial use already. A lot of people using it, probably some of you on this call. And again, as you apply it in the education space, I urge caution, because that is a market that will burn you badly if you don't do right by them. I'm going to skip through this in the interest of time. This is just a demonstration of how the technology would work. I didn't want to go live. I want to just come up with a closing thought. This you see on the left here is Manning Hall. That is, if any of you attended Brown University, you've probably been at Manning Hall. That was a picture taken in 1890. Anybody want to venture a guess at what this is? That's Manning Hall in 2003. Notice the difference? Plastic chairs, and they literally bolted a marker board. That's not a pull down screen. That's a marker board that they bolted on top of a chalkboard. So when you think about education, even our premier Ivy League institutions like Brown, they're really, really, really slow to adopt things, right? And it doesn't mean that you shouldn't continue to push. It just means that you've got to figure out, how do I make it incredibly valuable to them in order to use it in a meaningful way? Anybody know what that is? That's the Wright brothers. Anybody know what they told the Wright brothers? Literally, they told the Wright brothers, you cannot fly because it's a natural process. Only birds can fly because nature endowed them with the ability to fly. Well, you take an engineering principle and you apply it to a natural process. Guess what? You can fly. I was in Australia in February, and I took a shower at 34,000 feet on an Airbus, right? That was probably flying almost completely with AI, right? So take an engineering principle and you apply it to improve on human processes, whether that's with ChatGPT, with our Intellimetric engine for scoring, and you can improve on all of these things. So AI is really just an improvement upon a human process. And with that, I'll take questions if there are any, and encourage you to reach out if